Okay, hi everyone. I hope that you are doing great this night. Thanks for joining. Okay, so it's been amazing so far, and I've been seeing the amazing work we've all been doing, whether as new learners or as somebody who has, had some background knowledge of what we're learning. But at this very point, we're going to be moving to something, more interesting and something more useful for the path that we have chosen, and that is machine learning. So I believe that we all have this very material, so I advise that you download them. And there are several materials there, but one of the things I've tried doing is to create what is most essential and needed for this first phase. So when you download this, when you download the material that was sent, you will have machine learning, and inside machine learning we have a folder called data cleaning ML. All right. Under data cleaning ML, we have some certain things there which we are still going to go through. The inside introduction to machine learning, we have intro, we have machine learning lifecycle. Also, I placed one of the PDF documents that I also used when I was learning many years ago. All right, it was very useful to understand because of our time. We only have 4 more weeks to go, so we don't have all the time to learn every of the thing. But we'll look at the most important part, and that's why I've taken out time to create this material for this singular purpose. So congratulations so far. You've learned a whole lot, and I'm sure that you're already set and you're already building amazing stuff at your end. Just like we all know, the journey started from Python programming, and in the last 2 3 weeks, you've also focused on the programming that you've learned in Python. Then you now started doing some stuffs around, say you're not trying to analyze your data, so you learn about NumPy, you learn about using NumPy arrays. You understood the types of arrays. You can also how you can also generate that, your array and all of that. You also move to pandas, and we see pandas like an advanced Excel, which has the capacity to do everything you can think of in Excel, and even much more. So pandas is like a big guy. So if you say you can do analysis, pandas is one of the two or the libraries in Python that you should be by now very familiar with to do a number of stuff, from creating your data frame down to grouping your results, down to doing your selection, down to understanding the concept of loading your data, down to the concept of combining more than one data. You want to join data, you want to merge it, you want to do concatenation, all of those beautiful concepts. You want to undo missing data. All of these basic concepts is what pandas will give you. Then also, I know you are also been introduced. Of course, these things are going to be introduction, and you're going to really do the more deep work around them as you begin to practice. Then you've also done some visualization using either Matplotlib or Seaborn, which is very fantastic. So with this knowledge, because for you to move to building machine learning, to be able to call yourself a machine learning engineer, you must have been able to do the things we mentioned. You must, because even if you go for interviews, these are the things you are going to be asked. They want to know how your data analysis is solid, how your programming is solid. So programming plus analysis is what is like a prerequisite to doing machine learning. So today and in the next few weeks, yeah, we're going to be talking about machine learning. I know some of us are really pretty much waiting and ready for that. So in simple word, I believe you have this material. So I am looking at the material called intro. All right. So if you look at the machine learning, I try to make it very small so that you don't have too much cumbersome material. So intro. So we're going to be looking at this intro and this ML life cycle. So we start with this intro just to introduce you to some concepts about machine learning. So ML, or machine learning, is a branch of AI that focuses on building models. So that's like the first keyword you should take note of. We are building machine learning models. Some people also call it algorithms that enables the computer to learn from data. And the key thing is that with that being explicitly programmed for every task, all right, it just put in some data there, it learns the pattern from that data and is able to give you results. For example, look at it from somebody who used to post. Maybe you work as a registrar in an institution. You know the approach you guys used to use to give people admission. All right, those are the things you do. There are things you look out for before you tell, oh, let's before you make that decision of giving a student an admission or not. It's the same thing. So with that, just for the computer looking at these processes, the computer can then learn some of these approaches. The computer can then understand the way you go about your things. The computer can then check what are the very important thing to you as human. It mirrors that to be able to take decision. So the key thing we are doing when we are doing machine learning is what we call predictive analysis. When you are working with your NumPy, Pandas, Matplotlib, what you are doing majorly at that point was what we call descriptive analysis. You're trying to describe what you can find from the data. You're trying to describe what you can find from the data. That's what we have done so far. But this time around, we are trying to go a step higher by doing what we call predictive analysis. We want to predict the likelihood of giving a student admission. We want to predict what the student score in JAM will be based on some parameters. All right. So some of these things depend so much on data too. So in simple terms, machine learning allows system to think, allows your system to understand and improve by first doing what? Analyzing your data. So the first role, the first job of a machine learning expert is to be able to do a successful analysis. Oh, what are the features I have in my data? What are the missing data in my data? What are the real things that have been happening in this data? Because you are depending on that data to move to the predictive part. You are depending on that data to move to the predictive part. All right. So similar to woman learn from experience. All right, you learn from experience. You watch something and you over time you grab it and you can do that yourself again. And with time you even become an expert or a professional. That's apparently what is happening. Also, for the sake of first time bees, we have the types of machine learning. So machine learning is currently divided into three core. But of course, in the real sense, we have like two major ones that we used to always say. But the focus of this entire class will be on the first one, which we call supervised machine learning. All right. We'll pay attention more to the supervised machine learning. What does supervised machine learning means? It means that we want to train our model using what we call label data. Please put that somewhere. Using what we call label data. What does label data mean? It simply means that we have input and we have the output in our data. We have the input and we have the output in our data. For example, you want to predict if somebody is going to pass an exam or fail. In the data, you already have some input, some parameters that you are using. Then you also have a column that is the output. Maybe you already have pass there, you already have fail there, you already have pass somewhere, fail, pass, fail, pass, fail. That is supposed to be our expected output that the model should build. But because the model needs to have learned from previous experiences, the model needs to have learned from what has happened before. That is where supervised machine learning plays out. That we have our expected input and we also have our output. We have expected input and also have our output. So that picture is what we call supervised machine learning. Why? Because it has the input and has the output. It has the input and has the output. So there are many things you can decide to predict or that you can even decide to classify. For example, you want to classify if an email you receive is spam or not spam. The point is that we must have an example of, we must have a sample of what a spam email looks like and what a non-spam email looks like. So that means if you have an email, in the output we say maybe it is spam or it is not spam. All right. So at that point whereby in your data you have both the input and the output. Now we call the input our features. Please take note of some of these technical words, and that's what we're trying to achieve in this first part of the class. So this input is called our features, the makeup of your data. Why the output, we call them at some point, we call them label, we call them target. So you'll be hearing most of these languages as we begin to build. You'll be hearing labels, you'll be hearing targets. Also, we call the input at some point, we will call them independent variable. Independent variable. We also call the target, which is our output, we call it dependent variable. What does that simply mean? That our output is dependent on some of those features on our input to get results. All right, to get results. All right, we depend on that input to get result. All right, we depend on that input to get results, and that happens a number of times. So please have your notes and be taking notes, because some of the things I'm saying, you might be hearing them from the first time, and from the first time they need to stay with you. From the first time they need to stay with you. All right, from the first time they need to stay with you. So we call our inputs, we call them feature at some point. We also call them independent variables, and of course our target, which is the one we want to predict. We also call them label. All right, and we call them dependent variables. All right. Now another type of machine learning that we have is what we call unsupervised machine learning. So just like the word say, we are not supervising that one. Of course, we are still trying to predict something too. So what that simply means that we are working on some set of data, but this time around, we don't specifically have a target. We don't call anyone the target. It will just look at it carefully. It will look at the data carefully and understand what the problem that we are trying to solve is. All right. Understand what the problem we're trying to solve is. And some common tasks is what we call clustering. The picture of clustering simply means that we want to group our data into some points. Oh, maybe this is group A, this data will be group B, this data will be group B, C. Based on those clustering, based on those subgroups, all right, is able to learn and identify what our results should be. Like I said, based on our time frame, we are not able to go in depth into this type of machine learning, but just that you are aware of what is happening. And of course, we have the third one called reinforcement learning, which is the big guys in town right now, right? This involves learning through try and error, the same way ChatGPT was doing before, right? Our agent. So see it as an agent that interacts with an environment. It will receive what we call rewards and penalty. For example, at some point you can tell ChatGPT something because it's learning from you. You will say, who is the president of Nigeria? You say it's Mr. Israel. If you tell you that no, if he says Tinubu and you say no, it's not Tinubu, it's Israel, you say, oh, I'm sorry. So the president, so because he's learning from you, so it's a trial and error thing. Your enforcement learning is learning from us, all right? And that is a picture of agents. Also, some additional types of machine learning. We have the semi-supervised learning and we have the self-supervised learning. Like I said, for the purpose of this class and the scope we are following, we will just pay attention to supervised machine learning. Of course, we have many of them. I've mentioned them and I've also given some insight to them. Okay, so what are we going to cover under this machine learning class? The first thing we are going to pay attention to is our preprocessing. You cannot build a successful model, a model free from error, if you do not preprocess your data. And so we will pay more attention to that part so much. I'm going to cover all of these general preprocessing you will think of whenever you're working with a model, starting from the workflow of a machine learning model, down to cleaning the data, down to preprocessing, down to feature scaling, down to feature extraction, down to feature engineering, and down to feature selection. We're going to look at all of this because you cannot build a model successfully without preparing your data for that model. Without preparing your data for that model. Another thing we're going to look at is evaluation. What is evaluation? When I build a model, how is my model doing? Is it doing well? Is it doing bad? All right. Those are what evaluations are. And based on the problem we're trying to solve, we will know what evaluation can we use for them. I'm not going to talk about this yet so that I don't go into so much technicality. But as we begin to work, evaluation is how to know how our model is doing. All right. Is our model generalizing? What does that mean? Is our model performing well? Is our generalization? I'm going to explain some of these keywords as we begin to get into it. But the goal of evaluation is that that is the only thing that will tell us if we have built a model at all. Many of us, when we start now, you start getting models of 100% accuracy. You begin to get 90%. That's not enough. We need some evaluation to know, is this model doing well? Is this model correct? Is this model in the right form? These are the things we will check out. All right. And why the other thing we are going to look at, which we are going to pay more attention to, please carefully listen, because we are gradually getting into the real thing. Why the other part we are going to focus on is the model itself, and that is the module here that talks about supervised learning. Like I told you, we will only focus at this time at this type of machine learning model. Now, when we talk about supervised machine learning, what did I say again? What is the key thing you have picked from what I called supervised machine learning? What, in simple word, what do you think supervised machine learning is? Just want to see it from something. Anybody in the chat? What do you understand by supervised machine learning, by what I've said, or by what you have read, or what you know by now? When we say supervised machine learning, what comes to your mind? Anybody? Yeah, so it trains the model. Thank you. It trains the model with the label data. What that simply means is that you have the input and you have the output. Very good. We have the input. Somebody's already saying preprocessing. We're not there yet, though. Supervised machine learning talks about we want to build a model, all right, that has both the input and has the output, all right, because I told you that supervised machine learning does not have the output, all right, it does not have the output. So the key thing is that it has the label data, it has your targets there. That's what makes it supervised machine learning. You can supervise it and see, oh, based on this input, oh, this is the expected output. All right, it has the features, good, and has the target, very good. So I'm glad that you're gradually taking notes of the keywords. So when that is what makes, supervised machine learning, because it has the label. All right, good. Now, when we are working with, we have agreed based on the scope of this project or scope of this learning that we are going to focus on what? Supervised machine learning. Now, whenever you are working, you have agreed this is the type of model you want to focus on. There are two kinds of problems under supervised machine learning. There are two types of problems. No matter the problem I'm giving you to solve, all right, no matter the problem I'm giving you to solve in machine learning, it will fall under these two. Take note of that. It will fall under these two. One is that it's going to be a classification problem, or is going to be a regression problem. So once you have already agreed, you check the data. Oh, you've looked at the problem I'm trying to give you. You've checked the data. It's going to have two kinds of problems. So no matter what we are doing at this stage, there are two types of problems you can solve under supervised machine learning. The first one is classification, and the second one is regression. The question you want to ask me, so how would I know is classification, or how would I know is regression? One, the way you are going to know whether it is classification or regression is from your target. All right, is from your target. That's your output. Your output will tell you. So if your target is showing you numbers 20, 40, 60, 70, 80, 90, 100, all right, so your target, when it is number, when what you're trying to predict, all right, so that when what you're trying to predict is in continuous value. For example, they want us to say, oh, predict the house price, or predict somebody's jam score, predict how much we should sell a product, predict anything that has to be that you are trying to predict number. That is what regression problem. You get what I'm saying now? Regression problem. When what you are predicting is a class, for example, predict if it's going to pass or fail, predict if it's going to be a male or female. All right, so when what you are predicting, all right, when what you are predicting is a class, you are classifying your results. All right, either it is binary classification or multi-classification. I'm still going to come back to that as we begin to learn. There is a need to know that kind of problem, when you are predicting based on the class is a classification problem, because at times it can be confusing. Even for example, in my classification, my target can be 0 and 1, 0 and 1. It looks like number, but that is not just a number. All right, that is not just a number. It is more, all right, it is more like a class, as it were. If it says 0 and 1, even if that's the number you're having, as far as it's not a continuous number, it's not 0, 1, 2, 3, 4, 5, 6, 7. Even if it's showing 0 and 1, it does not mean that it is regression. It still means that it's a classification kind of problem. It still means that it's a classification kind of problem. It still means that it's a classification kind of problem, even when it is in an ordinal form. All right, it still means that it is a classification kind of problem. So please take note of that. These are very, like I said, I've made this material very simple. There are many things to learn, but I've brought the things that are very vital and very important on the journey. Now that I know I want to build a classification model or a regression model, I've told you what's another name for model? Algorithm. All right, algorithm, model. I'm saying the same thing. So once I know that I'm trying to build a classification model or algorithm, or regression model or algorithm, the next question is, what are the types of models I can build for either regression or classification? What are the types of models I can build for either regression or classification? So the first model we'll take note of for regression is what? Linear regression. Linear regression. This is for what? Linear regression is for regression problem. Don't forget, if you look at the small notes there, you will see that there. Logistic regression, please note, of course it's saying regression, but logistics simply means binary. All right, so logistic regression is for classification task or problem. Logistic regression is for classification task or problem. All right, don't forget what is binary. It simply means 0 and 1. It's just two classes that you have. Two classes that you have. Don't worry, when we pick these things one by one, we understand them. Also, we have the decision tree. Now, that means the decision tree can either be a regressor, which is for what? Regression problem, or decision tree classifier, which can be for what? Classification problem. You can see they are not very far from each other. It's just their extensions that tells you, oh, this one is for regression problem, this one is for classification problem, this one, that is what you need to know. So if you're taking note of what I'm saying now, you will have no problem in this class. All right, if you're taking note of what I'm saying, please have a note. This thing I'm saying, there are things that you can be asked in any interview, as basic as they sound. They are the things people want to know that you understand. All right, they are the things. So, and of course, people are asking, well, this is not the time you will submit assignments, a lot to submit. So please take note of these things. Once you understand them, they will give you a leverage. All right, so we have decision tree, we have support vector machine, both for but most of the time these are support vector machines are used for classification kind of problems. We have naive basis, which can be used for classification kind of problem. We have random forest classifier. We also have random forest regression. And of course, we have assembling, though we might not talk about assembling at this point or at this time. As you begin to grow, you will begin to take note of those other big ways of working. All right. So those are the things we are going to cover in this class. Any questions so far? I hope I've not lost you. I hope we are still on the same page. I hope my grammars and terminologies are not too big, but you need to start hearing them from now. So any question? Are we on the same page? If we're on the same page, what's this? Not really gang. I don't understand that. Please come again. The data or decision tree. Please come again. Don't worry. We are going to pick them. If I'm saying anything that you don't understand, don't worry. We're going to pick them as entity on their own. So this is just an overview. Binary means 0 and 1, not 0 and 2. Abigail. God is on the throne. Yes, we know that. Thank you. It's clear. Okay. Yeah, I didn't get random forest. Random forest is one. Okay, so random forest is one of the models we can build either for a classification problem or a regression problem. All right, either for a classification problem or a regression problem. Whether for a classification problem or a regression problem. All right, so don't worry, we're going to pick them one by one. So let's quickly look at another material. Somebody say, right on, Pastor. Does it look like a preachy section? It's okay. Okay, so let's go through. Please, where is this resources located? Download the ML zip file. We have two folders there. We have ML and we have data cleaning. Okay, so I'll move to another material under the introduction to machine learning. So the question now is, for anybody who wants to build a machine learning problem, there is a life cycle. What that simply means is that there are certain things that will show that you understand what it takes to build a model, and it does not change at any point, as it were. The only thing that changes over time is the kind of problem or the kind of data you are working with. And don't forget when we started this class, all right? Don't forget when I started this class, I told you about 3 ABCs of data analytics. I told you about understanding the business problem. What is the problem we are trying to solve? That has not changed. The second one is, what is the data I'm working with? And the third part is you're exploring the data. And of course, to this level, all right, from this level, you have been able to explore the data to the extent whereby you can analyze it. All right, you have done it to the level of analyzing it. You have done it to the level whereby you can visualize, you can generate insight from the data. All right, of course, that is also very important. So let's quickly look at all of these steps. Of course, based on our working schedule, we may not be able to cover all of them, but we'll cover to a good extent at this level that you are in. The first one is that we will all have to always understand the problem. All right, we will all have to always understand the problem. So we have to define the problem. Most time when I'm asking you to work on the project, I will definitely tell you what the problem is. You will always have that. All right, because right now we are in real business. We're not going to be talking from abstract. We'll be working with real data, all right, to do most of the things that we are doing. You have learned about your data frame before, that the one creating it, but now we have learned that level. We also do data and pre-process the data. So we define the problem. The next part is we collect. At this stage, we may not be the one collecting it. The data may already be available. So we have to prepare the data. So in building machine learning model, preparing the data takes more than 70% of all that you need. As I'm saying that, please pay attention to what we are doing. Pay attention to what we are doing. All right, pay attention to what we are doing. Preparing the data takes more than, if you can prepare data, if the data is clean, data is in its right form, you have done your preprocessing of your data. So preprocessing of your data takes more than 70%. Why building the model is just 30%? Building the model is the last thing, is the simplest thing you can think of. But preparing your data takes most of your time. It can take you days to clean your data. It might take you weeks to clean your data. And the more your data is clean, the better the model. It has a huge effect on your model. It has a huge effect on your model. Show me a clean data, I will show you a model that works well. So if you can prepare data well, if you understand the preprocessing well, 70% of the work has been done. All you need to now do is to plug your data into the model. And don't forget, at this stage, we are not really building the model from the scratch. We are leveraging on some of these models to work. All right. So cleaning data is very, very key. As I'm going to pay more time to show you some of the things you might need to do. Now, also know that cleaning data is based on what the data is. And that's why you have to pay attention to this process, because the data I'm going to use now might be different from the data you are going to use tomorrow. The data I'm going to use tomorrow will be different from the data you are going to use the next 3 days. because different data, different issues. But we are going to talk about general issues with our data. All right. We are going to talk about general issues with our data. All right. We're going to different issues that you need to look at. Even whether it's there or not, you have to confirm. Are there no missing data? Are there no missing record? All right. So you have to take your time to pre-process your data. We are going to talk about general ones, the things you should be able to do on your data once you pick up a data set like this. Boom. What are the things you need to first do? And that's the process we're going to follow in this class. What are the processes you need to first do? So whether it is there or not, you have to check. You have to check. So then, exploring inside, that is where you do your visualization. You don't just jump to models. You should see it yourself. You should see what's happening in the data yourself. You should use your matplotlib. You should use your cbom. You should use your plotlib to plot something out, to see it in pictures, to see what is happening. All right? You must do well to visualize it. We're not going to do that now because we've done that already. And if you have not mastered it, you have to understand it. All right? So you have to take your time, visualize what you have. Now, feature engineering. What is engineering? Simply means that you are trying to do some scientific work on your data to now prepare the data for the model. Please take note of that. The purpose of the feature engineering is for the purpose of the model. There is a way our data must be looking to make it match up for the model. That you have just screened data. For example, gender, male or female, male, female. We cannot, you get what I'm saying now? We cannot pass male and female inside our model because our model is expecting, don't forget, what is computer? Computer will only process binaries. So it's the same thing. Male and female will be very useful when you are plotting your bar plots. All right, your histogram. The male and female will make sense. Age range, it makes sense like that. But we cannot use that in the model. So the feature engineering primarily is for us to be able to prepare our work, to be able to prepare our data for the model. Now, and there are a number of things you can do. One of them is that, just take note of feature engineering, is that there are certain things we can do with feature engineering. One of them is that we can generate more features. Based on our own knowledge, based on our own research, we can decide to create more features. For example, maybe in your data you have date of birth. Date of birth is already available in your data. But you know that based on your date of birth, you can also get another feature called age. Why? By just subtracting the present year from the year of birth of that person. You know, that's an example of a feature you can decide to create. So the goal of feature engineering, one, is to standardize your data, is to remove the data that features that are not necessary. All right, is to do some standardization on your data, because at that point of modeling, all our feature must be binaries. They must be numbers, even though it is gender, even though it is present or absent. All right, the goal at that point of building model, at that point of pushing into our model, it has to be that those features are binaries. They have to be numbers, whether in their standard form or something. All right, so yes, normalization, analyzation, those are part of the things we might need to do on our model. So please take note of these things from this point, because there are some mathematical induction to what I am saying, but I want you to understand it from a use case point of view. We will not pay more attention to the mathematics, but understand what I'm trying to say. I will show you, but don't let that scare you off. We are not going to, that is the list of our worries, because all the maths I want to say, there is a library that will do it for us, but know that they ever exist, know their concepts. All right, understand their little concepts. All right, so that is exactly what we're trying to do when we're doing our model. All right, so if you want to build our model, we have to standardize our data. Now, after you have engineered your data, the next thing now is that you now have to split your data to say, oh, I have 1,000 data. Let me train my data with 70% of the data. Let me now use the remaining percent to know how my data is doing. Because the beauty of building a model is not because you build the model. The beauty of building a model is that when you now test the model on the data you have not trained it with, is doing well. For example, we have built a model in our place of work that is used to predict the score of staffs. Let's say presently now we have 100 staff. Let's say tomorrow we now have 1,000 staff. You know that we have only trained it with 100 staffs. How will that data do when we now plug that same model to another 900 staffs? The beauty of the model is not on the data we have used to train it. The beauty of the model is how it performs on the unseen data. That's the test data. Take note of that. The beauty of the model is going to be its performance on unseen data. On unseen data. So if I want to evaluate your model, I will not evaluate your model based on the data you have used to train it. I will evaluate your model based on some data that you have not seen. For some of you that have been joining competition, you will see that when you are training those competition, there is a train data and there is a test data. That test data has not been passed into the model at all. It will be used to test how your model is performing. It will be used to, please, I know some of these things are still big grammar, but at this stage, just take note of it. They will help you when we begin to move, because this is the life cycle of anybody who calls him or herself a machine learning engineer. You must know these things, and knowing it means you must be able to do it. So that you build the model is not the joy. The joy is how does your model perform on the unseen data. And that is why we at this stage we will continue to split our data into train and test. Some people used to even split it into 3 portions. One is train, one is validate, and one is test, just to be able to show how the model is doing across board. But at this stage, take note that we're going to split our data into the training and the testing. All right, into the training and the testing. And when we are testing, we will be able to evaluate it. Oh, he's doing well. This model is bad. This model is not doing well. And all of that. And that will begin to move us. And 2 ways we can conclude is our model overfitting or underfitting. As we move on, you will understand those words. Is our model underfitting, overfitting? Most time, models overfit. Most time, models overfit. Most time, models overfit. Okay? So now let's look at this life cycle in an image. Let's look at this life cycle in an image. The first thing, O1, is what? What is the problem I'm trying to solve? The second one is where is our data? The next thing is data cleaning and preprocessing. We want to clean the data, very close to preprocessing the data. Next one is we want to visualize data. Excuse me. The next one is feature engineering and feature selection. The next one, which model do I want to use? Is it linear regression? Is it random forest? Is it decision tree? Is it naive basis? Which one do I want to use? And also from research, based on your target, there are some models that works well, and that's where I am going to always send you to research. There are some models by research, you have to read about them. Every model we have mentioned has their uniqueness. Every model, we have many models that we can work with, but each of these models has their uniqueness. Each of these models has their uniqueness. Each of these models has their uniqueness. Every model has a uniqueness. Then model training, that's why we now train it. That's why we split it into our training and also split it into our testing. Also, we have evaluation. How is my model doing? Is it doing well? Is it underfitting? Is it overfitting? Model deployment, we can't talk about that at this stage. That means then they can use it. We can deploy it either as a microservice, we can deploy it either as an Android application, we can deploy it either as a web application, we can even deploy it in a device. Of course, if you deploy a model, you have to monitor it. Hope the model did not fail. Hope the model is doing well. Hope the model is not saying error when you have deployed it. So those are the life cycle. So all of this is what you should be able to do as you continue to build your career at the end of the day. And of course, if you are applying for any job, they will ask questions across any of these parts. All right, they will ask questions on any of these parts because each of them has so many key things and deep things that you must understand. I hope you are still on the same page. Now let's look at some of these things one by one, just for the knowledge sake. Problem definition. What does that mean? It means that we are creating a clear and well-defined problem for our entire machine learning process. For example, the key activity here, we have collaborated with stakeholders to understand our business goal. We have defined a very clear objective, a very clear scope, and a very clear success criteria to know how the model is doing. We have ensured that we have clarified on the desired outcome. This is what we want this model to do. And as we begin to work now, you begin to have an idea of what the problem is. The next part is data collection. Here, you will gather data that will be needed to build the model. Now, another key thing is that the quality of your data, I said that before, I'm saying it again, directly impact on your model performance. I remember I was working on the project with a US company. We just closed as a fellow in October. And the part of the project I was because I'm a Nigerian, so I was working with a company in Nigeria to solve a Nigerian problem at that fellowship program. So I was working with one of the teaching institute in the northern part of Nigeria. So we got all the data from them and all of that. But then it's another thing to have data, it's another thing to have quality data. Quality data is going to have impact on your model. If data is bad, it's not even about mixing data this time around. If the data does not have the kind of features that will make model do well, it's a lot of challenge building the model. So I had to find a way to align my data to the problem because the model was not doing well, because the data was not good. It didn't have features that can have effect. The features that has effect, if I use them directly, because in the model, you don't use a feature that the model should get. For example, I remember one of the tasks I was doing, I remember I did when I was working with an organization in Congo, Republic of Congo. I was trying to build a model to predict the likelihood of HIV, that somebody has HIV or not. Now, there is a feature there that once that feature is either yes or no, they already know if the person has HIV or not. That kind of feature cannot be used to build model, because by domain knowledge, automatically, even if you don't build model, by that alone, you will know what the model is. If you use a feature that by seeing it, you understand what the result is, your model is going to overfit. What does overfitting mean? I'm going to explain that as we move on. And what does underfitting mean? As we move on, I'm going to explain all of that. So in data collection, we talk about relevance, the quality, the quantity. The more the data, the better. For example, you want to build a model and you say you have only 100 records or 100 data sets. That's not good enough. Maybe when you're even cleaning the data, it's going to remain only 50. How do you build a model on 50 records? That's not good enough. So quantity is also important. Why over it? Quality is also important. Diversity. Diversity means that your data should have different scenarios. Everybody should not be male on all your data, because you will already have a biased result, because everybody in the data is male. Everybody should not be the same age. So there should be diversity in your data so that the model can learn from different people, different kind of information from your data. Okay, so we have data cleaning and pre-processing. So like we know raw data, because many of us are going to work in organizations, in companies where the data is going to be coming raw. It won't be like the one I'm sharing with you that does not have too much issues. All right, you'll be working with raw data, very messy data. You have to keep your hand busy because you have many stuff to do around it. So cleaning and preprocessing ensure the data is suitable for both analysis and modeling. Like I have told you, in the real world, in the real task, model development is 30%. While preprocessing your data, cleaning your data takes 70%. Even at some point, 90%. Model is not the problem. If your data is good, the model is going to be good. If the data is good, the model is going to be good. Another part is what? Exploratory data analysis. Here is where you want to explore. Excuse me. All right, this is what you want to explore. All right, this is where you want to explore in your data sets. This is where you want to explore in your data sets. This is what you want to explore in your data sets. Before we continue, any questions so far? Any questions so far? Okay, so please keep taking notes of the things that we are saying. Please have a note on what we are saying. They are very key things. They are very detailed things. All right, take note of them. Now, when we explore, you've done that before. I won't pay more attention at this point. That is where some of these things are going to work. Now, feature engineering. What are the possible things we're going to do under feature engineering? One is to transform our feature selection to select only the features that are most important. And of course, this knowledge of knowing the features that are important is coming from your domain knowledge. I've told you about domain knowledge before now. People who are experts in business, in marketing, they will be able to tell you what they, like I told you, that project, it was a doctor that had to tell me, this feature you are using to build your model is wrong. I'm just a data scientist. I'm not a doctor. I'm not an health practitioner. But you have to tell me and say, this feature is not needed. All right? These features are not needed. These features are not needed. So feature selection is based on your knowledge about the problem. And of course, your knowledge about the problem is from your research or from the guys who are the experts. They'll be able to guide you. All right? So somebody is asking the step orders in this order. Yes, that's the order. Yeah. You can master that process. That's the order you should follow to build your model. You can take note of that. That's the order. No, you can't have the same range of values, but we are saying that consistency and diversity in your data. You can't have the same number of males. It doesn't have to be. Data are not that perfect. You can have more males and more females. It doesn't matter. But the point is, your data should not follow one pattern. That's the approach. All right. So model selection. What are the things we look for before we select a model? First is complexity of the problem. Like I told you, based on some problems, there are models you can use. Based on the kind of problem you're trying to solve, there are kind of models you can use. All right. That's why you must always ask. Don't just jump on models. You should do your research. Don't just wake up and say, I will use random forest. Why? And those are the questions they ask at interviews. Why should you use why will you use this model on this problem? Because every model has their uniqueness. So based on the complexity of your problem, you can determine the model to use. Performance and interpretability. Also based on scalability, you want to scale the model. Also experiment with multiple models. So no one model can give you the best result. At times in a particular task, you want to try 2 to 3 models. All right? You want to try 2 to 3 models before you can now conclude which model performed well. Performance of a model is based on the data. Even though you have read about, you can use random forest for this kind of problem, or you can use this kind of model for this kind of problem. One of the easiest way is always by experimenting. Modeling is by experimenting. All right, modeling. So you will experiment so much. Well, so get ready for that. Just one task, you can be checking 3 models, 4 models, just to be able to be sure that you have explored as many models as possible. Don't ever submit a task for me and tell me you just check one model. I won't even check it at all. You have not done a solid work. A solid work, we check more than 1 models. We explore as much as possible. We experiment as much as possible when you work. Okay, and of course the other part is model training. That's why you now train the model. All right, you optimize the parameters, you validate to ensure that there are generalization on unseen data. I've told you the goal of training a model is that it does well on unseen data, is that it does well on excuse me, is that it does well on unseen data. Okay, and we also have model evaluation. How is my model doing? How is my model doing? So if you can follow this step by step, all right, it will guide you. You already know what you want to do. Even if you don't know how you don't know how to code, you already know what should be next. And that's why I'm showing you all of this. There are steps to step. You cannot leave one step and go to the other one. No. That's why building model is not too difficult, because it has predefined steps. Are you getting it now? It has the predefined step. If you don't do this step, you can't go to this step. There will be error because data is not clean. All right, there will be error at this stage because you have not selected. You cannot train the model that you have not selected. So that is the build up, or whatever it is that you are doing. That's the build up, and of course you have the model deployment. Of course, we won't do that at this stage. Also, we're not going to do monitoring because these are high level work, not necessary at this stage. Our goal is to be able to build a model, able to evaluate our model, clean our data, and all of that. So, any question on somebody wrote model building is not difficult? Yes, if you have your data clean. Is modeling the data clean? No, of course. No. Modeling is predicting. Yes, the steps will follow accordingly. Any question before we go on our short break? I know I've said a number of new things, but the goal is to get you familiar with the processes so far. Any questions so far? Are we to train all model we try? So what it means by saying you try model is that you are training the model. All right. So what it means by saying that you are trying a model means that you are training a model. For a minor problem, do we still need large amount of data? Yes, the more the data, the better the model. So that's the logic. The more the data, the better the model. What do you mean by model? Did you just join this class? Hey. Yeah, I will obviously say something that looks like that again. Model means building algorithm, trying to do a predictive analysis. So we have looked at these two guys. Like I said, please, this particular material here, this material here on AAAMLP, it says approaching all machine learning problems. So it's going to be very useful. It's going to be very, very useful in this journey, even outside the class. I recommend that. So it has a lot of stuffs, but after you have gone through these things, you can always go back to it. Please, machine learning is experimenting. It's about research. The more you research, the more you're able to do. All right. So let me look at a few other questions before we go on our break. And once we return, we'll start with data cleaning. Yeah. So we start with this data cleaning and all. Okay. So what's the difference between data science and machine learning? It's just grammar that we are blowing. We say that machine learning, but data science means a whole lot than being a machine learning engineer. Machine learning engineer, you are very clear about what you can do. Data scientist has a whole lot involved. You can do NLP, you can do the computer vision, you can do AI, you can do data analysis and all of that. All right, so that's machine learning is more specific about the role. Data science is like the big name for doing analysis, doing data science, doing machine learning, doing natural language processing, doing computer vision. So that's like the big name. Yeah. So the science of working on all the phases of data is data science. But machine learning, you are specifically saying that you can build a model and all. How do we know which of the model to use on the data? It is by experience, it is by experimenting, it's about research. That's factors to consider before settle. I'll answer that already. Experience, experimenting, and all. Do I have do I need to know advanced Python before knowing how to train the model? The goal of this class is to train the model. So as far as you understand Python, you are still fine. And that's why we are here. We sort for data by ourselves or is it given to us? In real scenarios, if you are working in a company, they will give you the data. If you are working on a project, they will have data for that. So it depends on where you find yourself. Unless you are the one that decide to want to work on a particular problem, maybe that does not exist, or that you want to try and get data from. So you have to source for that yourself. Something like I give you, I say go and source for data. That is why we spoke about platforms where you can get data, like cargo.com. We have any data there. Zindi.africa, there are data there. And there are other repository you can get data from. And of course, personal company data too. If you are working as an intern or as a junior staff, they should be able to give you access to their data. So pick it up from here. So we got on our 10 minutes stretch your body. I also need to take water. So we come back. What's the time now? The time is almost 8. So by 8:10, we come back, get refreshed, and we get to business. Okay, so welcome back, everyone. I hope you took some water. So we're moving on, and we will start today with tackling and some of the things we've been learning before now will be handy. And we are not going to be learning really how to like write code now. We are learning processes, and I want you to see it from that point with the knowledge that you have with your Python programming, a little bit of using importing and using libraries. So you should be familiar with a few things. Of course, you don't as you begin to do more, you have more pattern of codes and all of that. But that is not really the big deal. Just pay attention to the approaches we are using. It's very key because you don't have time to explain code line by line. That's not the goal at this time. Like I've told you, codes are everywhere on the internet, but you will be able to write your code well if you understand what you want to do. And that is why nobody is stopping you from using the light of ChatGPT and thereabouts. Nobody is stopping you from using them. But you will only be able to use tools like that when you understand what you're trying to do. Okay? Oh, sorry guys, I am still muted and I've been talking. So sorry. So sorry. Okay. So what I was trying to do is to change my screen. Yeah. So yeah, is what I wanted to show. Okay. So I spoke about data cleaning is the next thing we're going to be doing. Yeah. Don't worry. I'm going to go over it again. It's from my end. I hope you can hear me now. Yeah. Okay, so good. So we're just about to start. We're just about to start data cleaning, and I spoke about the parts that data cleaning, the goals, and all of that. I said that already. So to begin, I'm using my Anaconda Navigator environment, and I'm using Jupyter Notebook, Jupyter Lab rather, so that I can run my code. And I mentioned that there are four essential data cleaning you need to do. The first one is to remove unwanted observation such as duplicates, relevant entries, or redundant data. Also help reduce noise and improve model readability. We are to fix the structural errors, but such as the format, the naming convention. We are to manage outliers. I'm going to explain this when we start working. But outliers means extreme values that are skewed in the model, so it's going to affect the model performance. For example, imagine that a store is going to sell more during Christmas time than usual, right? That the person is not selling at that point does not mean that that's the picture or that is what is really happening in the store. That kind of information cannot be used to make decision. It's just an extreme value. It's just an outlier. It can happen. It does not mean that is what is going to be happening in the data. All right, that one student got 400 over 400 in jam. That's outlier. Everybody cannot get that. So that kind of information is an extreme value, and we cannot use it to take decision. We can also not push such data into the model. That is what we mean by outliers. I hope that is clear. Don't worry, I'm still going to pick all of these guys up. I'm still going to pick all of these guys up as we move. And of course, missing data, there might be missing data in our model that we're working with. Okay, so now to implement some of these things, the first thing first is to import your necessary library. So for now, I'm going to import NumPy and pandas, NumPy as PD and pandas as NumPy as MP rather, and pandas as PD. Like we have been told, if you are using Anaconda, these two guys are already installed in your environment. You have to follow the line. The next thing you have been taught about how to use your pandas to read your CSV file. So the file I'm reading, so this one you won't have any issue because most of the files I'm working with are already in that directory. So this is my Titanic data set that I'm working with here. So if I run this now, all right. So what is happening here is to say df equals to pd.read csv Titanic dataset dot csv df.ed. All right. So what is happening here? Can you hear me now? Can you hear me now? Okay, good. So if you look at where we loaded the data, the first thing first is to import the necessary libraries, import numpy as np, import pandas as pd, right? The next thing is to load the data, where we have pd.read csv. Like I said here, the data set are already here, so you won't have too much issues having directory issues. So everything I'm working with are all here, so you don't have any problem with that. So pd.read csv, I say Titanic dataset.csv. Like I mentioned, just in case you don't have the details about the data, you can come online and search for Titanic dataset information. My own default browser is already, fixed with ChatGPT. So here is the dataset. I opened it here, and under the data, I can see many information so that I can understand what each of these features here mean. Variable called survive is survivor. All right, survivor means that does the person made it? Does the person made it? Is what is here. All right, so 0 means no, 1 means yes. P class, ticket class. So 1 means first class, 2 means second class, 3 means third class. Sex means the same thing, gender, male or female. Age means age in years. So SIPSP means the number of siblings or spouses aboard the Titanic. Batch, it means the number of parents or children aboard the Titanic. Ticket, the ticket number. Fare, passenger fare. Cabin, cabin number. Embark, port of embarkation. C is either Cherbourg, Q is Crystal. So you can see that this gives us an insight to what each features, because you must know what they mean. You must know your research. So, but of course, they might also have this in the business problem. It makes it clear you have to understand what each of those things mean. All right, you have to understand what each of those things mean. This is what I was sharing. Somebody said they can't see this. So under this, for example, you will see the data dictionary, where you are seeing the variables and the definition and the keys, the values there. Survivor means survivor. 0 means no, they did not survive. 1 means yes, they survived. P class means ticket class. 1 means first class. 2 means second. Third means third class in the Titanic. Sex means the sex of the passengers. Age means age in years. SIPSP means the number of siblings or spouses aboard the Titanic. Patch means the number of parents and children aboard the Titanic. Ticket means the ticket number. Fare means the passenger fare. Cabin means the cabin number. Embark means portion of embarkation. C is Cherbourg, Q is Queenstown, S is Southampton, right? So this gives you, some edge into what each features in the data means. That was what I was saying. This gives you some edge into what each of these data mean. So with this now, we have an idea of what each of these data mean. Also, you can check information. What purpose of information is to be able to see all the feature again. All the columns are the same thing as feature. Don't forget that. And here we can see the survivor, the page class, the name, and all of that. We can see the passenger ID is now integer. Survived is integer too, that is numbers. P class is also integer. Name is object, which is obviously strings. The sex is also object. From what we can see, is male or female. Yes. The age is float, that is as decimals. From what we are seeing here, SPI, integer, passenger integer, ticket object because it's just like special character too. Can you see that? A slash. So this is an object, which is what we are seeing here. The field is float. The cabin is object. The embark is also object because they are classifications. Now the shape, df.shape, what does that shows us? The df.shape is going to show us the number of records, the numbers of rows and columns in the data is what dot shape will show us. So here it tells us that we have 891 records, which is 819 rows and 12 columns. So here now what have we done? We have been able to load our data and we have been able to get some information about our data, all right, which are going to be useful as we move on. So the next step is to check if there are what duplicate records. So what method do we use to check that? DF, don't forget what's the DF? That's the data frame where we store our data. Whatever name you have called that is what you're going to be working with. All right, whatever name you have called that is what we're going to be working with. So if you go back to this now, you see DF dot duplicate. What that simply tells us, when you are seeing false, so it's returning a Boolean series. False means it's not duplicated, right? That's what it means. So, and of course, you can do dot sum just to know the number of duplicates that are there. So you can see with this, what this conclude, it checks all through all the records there and is able to conclude that there are no duplicate data. There are no duplicate data. Now, let's check this again just to show you before we do what we have here. df dot info. If you look at this carefully, you can see that some of them are integer. And like I told you where we started, that no matter the data types you're working with, the easy conclusion of each data is that you are either number or you are an object. Is that our features are numeric or they are categorical? Numeric features or categorical, no matter whether it's a float or whether it's an object or whether it's a boolean or whether it's an integer and all of that. Our numbers are in that format. Those two are the easy way to conclude it. If you are not a number, you are an object. If you are not an object, you are a number. All right. Please take note of that. Take note of that. Take note of that. All right. Is that you are? So those are the two ways to conclude on your features, whether irrespective of the data types. The easiest way to conclude is that if you are not an object, you are a number. Is that numeric or categorical? Okay, so the next step we took here is to be able to identify the columns, whether they are numeric or categorical. Whether they are numeric or categorical. So to know categorical, we are saying that it should select all the columns in our column.name. Now, if you do df, so that you can know these things too, when you say df.columns, this attribute shows us all the column names. All right. So this is what happens here. Shows all the column names. So you might have used some of these things in your previous classes, but we are saying them again just to take note. Shows all the column name. Okay. So now to get the categorical columns, we are using a loop. You should loop through the column name. If the data type is object, that means it's a categorical feature. While numeric, that means if it is not categorical. Like I said, at this point, we don't have time to start talking about code by code, but take note of what you're trying to do. You don't need to cram code. You just need to know what you're trying to do. You can always replicate that code again. If you copy it and you change things there, everything will still work. All right? Everything will still work. Everything will still work. All right? So that's like the first thing to take note of. So now I want to print all the categorical features. I pass my concatenation. Numeric columns, I pass that. So if I run this guy, you can see the result here. The ones that categorical columns here is the name, the sex, the ticket, the cabin, and the embarked. The ones that are numeric features are what? Passenger ID, survived, P class, age, SIPSP, badge, and fare. Okay, so now the next thing I check here is the uniqueness of some of these features. All right, what are the uniqueness? What does that mean for categorical feature? I want to check what is the uniqueness. For example, name. That means we have 891 unique names. In the sex, we have 2 unique names, unique sex, which is either male and female. Ticket, we have 681 unique tickets. In the cabins, we have 147 unique cabin. Even though we have 8, we have how many records? Even though we have we did an 891 record, but these are the unique records we have. And from the embark, we have only 3 unique value. We can use number of unique for features that are that are categorical. So there are some features, there are some methods we use as you begin to work, as you begin to make your research, and as you begin to ask, you will know them. And like I said, you don't need to cram anything. For example, I can come here. Let me share this. If I come to ChatGPT and say, if I come here now and I say something like, I need the Python code. So you don't need to crack anything. I need Python code to check the uniqueness of a categorical feature. All right, or a categorical column. It will give you an idea of what the code should look like. So you don't need to cram the code. All right, but you should know what you want to do, even if you don't know the code. And that's why I'm showing you this. All right, in all of this, what you are seeing from the code, you should understand it. Here is importing pandas, is loading my data, and is using this guy, all right, to check the uniqueness. But of course, it's asking for column name. I have to be the one to now change it to whichever column name or the list of columns that I'm working with. So if we say this is for the column name, if I copy this, all right, so if I come here now, so you can see that if I post the code that he gave me, just for example, if I post it here, I need to edit this column name. Is DF the name I'm using? DF is the name I'm also using. So column name, what will I pass? I pass category column because it's more than one that I want to check their uniqueness. So why am I showing this? So that you know that you don't need to cram any code, but you need to know what you want to do so that you can ask the right question and get the right answer. All right? So I can ask the right question and get the right answer. I'm showing you this because, are we going to depend on AI? Of course not. But that's to help you know that you don't need to cram anything. All right? It's for the purpose of not cramming anything. It's not that you need to depend on it. If you write your code, fine. If you need guide to write your code, fine. But the end goal is that you should be able to write your code, all right? Whether with supervision, whether you need help. Nobody knows code F-Ed. I'm not coming here to tell you I know code F-Ed, but I know what I need. All right. So nobody's asking you to depend on AI. Get it clear. The goal is you should not cram code because there are many codes outside there. All right. There are many codes outside there. But the goal is know what you need to do. Know what step you need to do. Because like I said, we don't have the time to start saying yes. So in this line, what we want to explain is the part that what are the processes you need to follow. We have so much to check in all our notebooks. All right. But if you know what you are doing, if you know what you are going to look at for, coding is going to be the list of your worries. Your worries will be what you want to do. Now, I've been saying that from the beginning. Codes are everywhere. You will get your answer but do you know what is in the code? Do you understand what we're trying to say? That's why we're in this class, to explain why we are doing this, not to not teach you, oh, this is the code. This is why you should do this. That's the key thing. Okay, so let's continue. So here we check the uniqueness. The next step we need to check here whenever we are working is to check if there are missing values. So what is the method we use for that? We use is num.sum. All right, is num.sum. This will give what we need to check for missing value. This is what we need. So what does that mean? Passenger.id does not have any missing value. Survived has no missing value. P class has no missing value. Name has no missing value. Sex has no missing value. Age has some missing value. You can see 177. out of 891. SPSD, no missing value. Excuse me. Patch, no missing value. Ticket, no missing value. Fear, no missing value. Cabin has 687. That's a lot of missing value. Embark has 2 missing value. All right. But this one we put here is to not get the missing value in percentage. That's why we are having this part of the code to get our missing value in percentage. The missing value in percentage. Because like I told you, when you write your code, you should comment it. That's very, very important too. If you send me codes and I'm seeing that you're not commenting it, I won't come and ask you and say, your code, what's happening here? Your this, what's happening here? It's very, very important too. It's very, very important too. When you write your code, it helps you to also master the process of writing your code so that when you explain it, you can, when you write your code, you also understand what you say to check the missing value in percentage. Okay, so this is what we get now. So you can see age has about 19.87 missing value. Fear, which other one? Cabin has 77%. That's a lot. The percentage is able to give you a picture. And back has, about less than 1%, as missing value, just to show you that. Now, the next thing you might want to do, depending on what you're doing, now the next question you want to ask yourself, there are missing value here. What should I do? Please note, your first job is not to drop a missing value. Your first job is not to drop a missing column, a missing feature. Your first job is to look at it. All right. Your first job is to look at it. Let's look at it critically. Now, what are the notes you need to take here? One is that you have to check what percentage of data is missing. If 687 is already missing the data, that's more than 70%. So it's not advisable to now fill that kind of data. But 177 is not too much of a data, right? That we are working with. Okay. So that's one thing you can decide to look at. So what this guy is doing here is that he wants to drop all these columns because of their missing data. And of course, some of them are also not relevant. There is no time you will build models and you will need people's name. All right. Information that are personal. We try to use data that are anonymous. You don't need people's information in your data. So that is why you can see here the things that we are dropping. We are dropping irrelevant and features that has every missing data. So if the data has some irrelevant data, for example, information that are personal, like the name, is a straightforward thing. You don't need the name of a person when you're building a model. When you're working with data sets, you have to drop such feature. The tickets, we don't need the ticket of the or if you look at the problem. So what is the problem? These are people who possibly took a plane. All right, who possibly took a plane. We want to know, did they go to their destination? Did they die? All right, the ticket, of course, at that point is not as important to be able to predict it. Of course, it doesn't mean that we don't want to have information about them or we don't want to know them. But at this state of building model, they will be irrelevant for the problem. Same thing with the cabin. Why are we dropping cabin? Cabin already has 77% missing data. So when we are collecting the data, 77% is already missing. There is not too much thing we can do with that. All right? There is not too much thing we can do with that. So here we are dropping the column. All right? Here we are dropping the column. DF1 is dropping the column. Now, this is temporary. It's not permanently. Temporary. All right? We are dropping the column temporary. Well, if you look at the second line here, we are also dropping M back. But look at this. We are dropping MA, missing records only. Here we are dropping missing rows only. Permanently. Now, how do I know permanently? Whenever you are seeing in place equals to true, you should have learned that in place equal to true, All right. In anything you are doing, you are saying that whatever you are doing should work or should happen permanently. Whatever you are doing should work or should happen permanently. So that's what is happening. So take note of the way we are dropping. Here we are dropping our columns, but because I did not introduce in place to be true, is dropping this temporarily inside df1. That means if I run my df again, all these columns will still be there. But because I have assigned this operation inside df1, it's going to have dropped these guys temporarily. Then you can see, why am I dropping only the record? Because this one only has 3. Look at this, only has 2 information that are missing. So I can just drop those 2 those records and move on with life. All right, and move on with life. That's what is happening there. And move on with life. All right, and move on with life because it doesn't have too much information missing. Why? The next thing, if I have to fill the data, age has about 19.87, almost 20% missing. I can still fill that. So now another knowledge that you should take note is that whenever we want to fill data, we check it out. Is it a numeric feature or is it a categorical feature? So now the question now, is age numeric or categorical? Don't forget whether it is float or integer. We will classify them under 2 sections, numeric and categorical. So age, is it numeric or categorical? Is age numeric or categorical? Yeah. So somebody saying age is categorical. Age 1, 2, 3, 4, 5, 6. Age is good. Age is numeric. All right. Age is numeric. So if age is numeric, that means most of the time when we want to fill a column that is numeric, please take note that we used to fill it with the mean or the median, but most cases is with the mean. So if you have to fill, you check out this column. What is the data type? Is it numeric or categorical? So if it is numeric, that simply means that we can fill with the mean. Why? If it is categorical, we can fill with the mode. Take note of that. And of course, you can see in place true. That means this process should happen and be stored permanently. This process should happen and be stored permanently. You can see the things you need to be doing before you can even think of building model. If you don't do these things, you cannot. And the beauty is you can always replicate the process. But what we are going to do, imagine I'm loading a data that does not have any missing data. I don't have to drop anything. Imagine I'm loading a data that does not have any missing record. I don't need to do missing that. I don't need to drop anything. I don't need to drop any column unless I want to drop irrelevant columns based on the problem I'm trying to solve. So what I'm trying to show you is the real way, is the real approach when you are working on any project, when you are working with any task. All right, when you're working on any project or when you're working on any task. If somebody is asking, so let me look at questions because I'm going to stop here today and pick it up from here tomorrow. Please, sir, is it addressable to drop missing data deliberately or drop the missing data based on higher percentage? So that's the first way. So do all your checking. If it has more than 70% missing, you can drop such column. If it has few records missing, you can drop NA. That is, you are dropping those records. When you see NA, you are dropping those records. All right. Why are we dropping embark? We're not dropping embark. We are dropping the missing value in embarked because it only has 2 missing value. That is, out of the 891 records, it only has 2 of them that are missing in the value. So we are dropping only those 2 guys that are missing. We can also decide to fill them. All right. Why do we use mean and median? I've mentioned that when it is categorical, it is mode. Those are research. Those are standards of handling it. Or you can even use model to fill it. Those are standards. What if the missing data is an outlier? Outlier is an extreme value, which means that the value we are having in missing data, all right, the value we are having in missing data is not outliers, is the number of missing data that is not there. All right. So outliers is when we are checking the value. For example, if it is let's say for example, it is people's score. People have been getting between 100, 120, 300. Somebody now score 400. That is outliers in the data. Is the value though, not when we are, I can say that, not when we are, what's the word? Not when we are trying to check if they are missing value or not. All right. So please in real world scenario, do we make decision on what to drop by ourselves or do we need to ask our boss? Yes, good question. In real scenarios, you need to ask questions. You need to, but of course, what I've told you now are the basic approaches, all right, in handling missing data. But that is subjected to the kind of project you are doing, subjected to your boss, and all of that, right? So it's all about domain knowledge. Also is very key to know what to drop, especially the part of the irrelevant data, irrelevant features, all right, that you need to drop. Okay. Can somebody tell me what we are to fill with categorical? So if the feature is categorical, you fill with the mode of the distribution. Are we going to have this material? You already have it. It's already in all the platforms. There are some files that comes with unnamed. Yes. So some comes with unnamed. Automatically, you have to draw that unnamed. The unnamed most time is like the index that you are seeing in your data. So most time you drop that. Yeah, somebody already mentioned that it depends on data you are working on. Yeah, some of them come with unnamed, which are always a replicate of your index. Index is the 012 that you are seeing beside your data. Won't outlier affect the mean you are trying to fill? No. At mean is going to look at all the values and place that. It doesn't have issue to that. How do we undo outliers? We're not there yet, but I've mentioned that already. Outliers are either above the scale or below the scale. So does code function needs to be followed step by step to clean that or build a system? Yeah, it's always adaptable to do follow this process. What if the outlier is also the median? I've answered that already. Okay, so those are the key things we are going to start with. So tomorrow we start from talking about outliers and how to undo it. Somebody's already asking, will we undo that in tomorrow's class? So any other question? So please, our advice, make sure we've said a number of things. I know I've said a lot of things that is possibly new, possibly hearing them for the first time and all of that. But then the key thing is, please watch this video. That's the first assignment. Watch this video again. All right. You said a lot of stuff that you need till the end of the class. All right. Till what you need to the end from now to, like, even till forever. So you have to take your notes. You have to, have your own notes. You have to understand these concepts because that is what they are going to ask you in the interview. That's what they're going to ask you on that project. You are trying to apply for something. All of these things we are saying, that's I'm trying to explain them from a use case approach. Once you understand the flow, you are not going to have a problem. But if your focus is the code, that's already a challenge. But if you are paying attention to the things you're supposed to do at every moment, before I move from here, this is what I'm supposed to do, this is what I'm supposed to do. Even if you use this, my material I have, you can use it to replicate over any other data sets. All right, over any data set. The only thing is, if I check if they are missing data, if it's not there, do I need to drop anything? No. If I check for duplicate, if they are not duplicate, do I need to drop anything? No. Do you get it? So all of these are the standard thing you will do. All right, they are the standard thing that you will do. All right, but you must try. You can't just assume they are not missing data. Did you check it? Oh, they are not this. Did you try it? So the goal is that you must do, because you have to make your data as clean as possible, so that when you get to the model part, there are no issues, because there will be certain many issues if you don't clean it well. All right, there will be serious issues. But trust me, if you follow and take note of the things we are saying, you are good to go. So thank you for joining today's class. We pick it up from where we are. Please, I advise you, make sure that before you come to tomorrow's class, you have tried what we did in today's class. All the things I said, you can say them again. And trust that if I'm going to set any question, if I'm going to set any question on machine learning, all of the things we have said today are going to be all the most that you see in the questions, right? Like I don't know how to set difficult questions, but I know how to give you challenging task, because that's the real thing. All right. How do you handle subcolumn? I don't know what that means. What subcolumns? All right. So guys, we call it a day to here, and we pick it up from here tomorrow. Thank you. Good night, everyone. If you have any question, you can also still drop that in the chat.